Okay, so when we're evaluating a definite integral, such as this one, the lower and upper limits are in terms of x because we have the function in terms of x, and we're evaluating that integral in terms of x. However, when we do our substitution, we're now writing our integral in terms of u. So instead of x, we are going to need to change our limits. Really, that better word would be boundaries. Okay, so that they're in terms of u. So what does that mean? If we let u equal to g of x, just like we did in the previous, we are undoing the chain rule, and our original functions in terms of x, these a and b boundaries now need to be evaluated in the g function. We need these lower limits, lower boundary and upper boundary, to be in terms of u. Okay, so we need to change the upper boundary and lower boundary to be in terms of u. Okay, so we're going to look at how to do that in this question. Now, I know this is an exponential function, and it's from chapter 8, and you're not responsible to know it, but I'm still going to go through this question. The derivative of e to the x is e to the x. So it's really straightforward derivative. You will not be tested on this. Okay, so the first thing that we need to do for these on derivative or definite integrals is we start it out the same way and we say let u equal. So what do I want to let u equal? I'm going to let u equal to the root of x in this question. And the derivative of this would be, well, maybe it's easier to write it as x to the power of a half. The derivative of that would be 1/2 x to the negative a half, or root x. And then when we rearrange this, so I could write this as 1/2 root x. Okay, so when I rearrange this, I would end up with dx is equal to 2 root x du. Okay, so again, you don't need to know that derivative, but you should be able to manipulate these no problem. And then the second thing before I actually do the substitution is, this is the added new piece. I need to find the new boundaries. Okay, so what are my new boundaries in terms of u? So I'm going to do my lower boundary. When x was equal to 1, what would u be equal to? Well, I said that I'm letting u equal the square root of x. So the square root of 1 is 1. So it turns out that my lower boundary is going to stay the same. Now the upper boundary was 9. So when x is 9, what would u be? U would be equal to the square root of 9, which is 3. So now I have my new upper and lower boundaries, and now I'm going to make my substitution. So now I'm going to go from 1 to 3, and I have e to the power of, instead of root x, I have e to the power of u on the square root of x multiplied by 2 root x du, which is replacing my dx piece. And then in this process, that square root of x is going to cancel, and what I'm left with is everything in terms of u, including my new boundaries. Okay, so it's really important that my boundaries match up with which variable I'm working with. So what am I left to do? I can take my 2 out, and I'm asked to integrate from 1 to 3 e to the power of u du. Now the great thing about e is his derivative is e to the u, so his antiderivative is e to the u. Funky little guy that he is. Okay, so the fourth thing I'm doing, well, we'll just leave it as black, that's fine. The fourth thing I'm doing is actually evaluating this. So e to the power of u is the antiderivative from 1 to 3 is equal to 2 times e to the 3 minus e to the 1. And there's really not much left I could do with that. I could maybe factor out an e. That's it. And that would be my answer. There it is. Okay, let's try one where it's a function that we are familiar with how to do. Okay, so this is not in your lesson booklet. I've added in a couple of extra examples so that you guys are not working with chapter 8 antiderivatives and derivatives, okay? Okay, so in this question, the first thing that I'm going to do is figure out who is u. So let u equal to, I'm going to choose the stuff underneath the radical. So 4 minus x squared. So du dx. So the derivative of 4 is 0. The derivative of negative x squared is negative 2x. And when I rearrange that, dx would be equal to du on negative 2x. And then the second thing I'm going to do is figure out my new boundaries. So my lower boundary, when x is equal to 0, what will u equal? Okay, so 4 minus, so you have to figure out what your u is, 4 minus x squared. So 4 minus 0 squared will be 4. That's my new lower. And my upper boundary will be when x is equal to 2, u is equal to 4 minus 2 squared, which happens to be 0. We're going to keep those as lower and upper boundaries, okay? So the third thing is now I can actually substitute it in. Okay, so the integral from my lower boundary turns out to be 4. Okay, that's the lower boundary. The upper boundary, even though smaller, is 0. Keep those, okay? So we're going to go from 4 to 0. X multiplied by the square root of u, and then my dx is du on negative 2x. All right, and then I have the x canceling, and I have the constant negative 1/2 that I could pull out the front. And I'm going to take the antiderivative of u to the half in terms of u. All right, step 4. I think we haven't used step 4. So I have negative 1/2. And what is the antiderivative of u to the half? So when you add 1, you get 3/2. Divided by 3/2 is the same as multiplying by 2/3. So hopefully we can start to flip those fractions. And before I evaluate this from 4 to 0, I can see that these 2's are going to cancel. So maybe let's just do that right away. And so what I'm going to be substituting in for my, I can just do negative 1/3 u to the 3/2 evaluated from 4 to 0. All right, and then I'm going to put my 0 in first because that's my upper boundary. So 0 to the 3/2 minus negative 1/3, 4 to the power of 3/2. What does this equal to? So the first one's just 0. And 2 negatives make a positive. 1/3. What is 4 to the power of 3/2? So the square root of 4 is 2. 2 to the power of 3 is 8. And so my answer turns out to be 8/3. Okay, I've put in one more example that's new, a trig example. Notice how this has the variable theta, so this is in terms of theta. That's just notation stuff. All right, so what am I going to let u equal to? Always look for the derivative. So if I let u equal to sine, I know the derivative is cos, so that's helpful. Du d theta would be cos. And when I rearrange that, d theta will be du on cos theta. And then I'm going to find my new boundaries. So my lower boundary when theta, not x, is equal to pi on 6, then what does u equal? Well, u would equal to sine of pi on 6, which is equal to 1/2. And my upper boundary would be when theta is equal to pi on 2. Then what does u equal? Then u is equal to sine pi on 2, which is equal to 1. Okay, now I have all my pieces for my substitution. So I'm going to go ahead and substitute. So I have, grab my cheat sheet again, that I'm going from pi on 6 to pi on 2. I'm just going to rewrite the original function, cos theta on sine cubed theta in terms of theta is going to be evaluated now from what's the lower boundary, 1/2 to the upper boundary of 1, cos theta on, sine is my u, so u cubed, and then my d theta is being replaced with du on cos theta, and then my cos thetas will cancel, and I'm left to integrate in terms of u. And there's no constant to pull out this time, but I might just rewrite that u as power of -3. And then I'm going to go ahead and integrate this. So the integral of u to the -3 would be u to the -2 on -2. And I'm going to evaluate that from 1/2 to 1. So I have -1/2 u 1 to the -2. That subtract -1/2 1/2 to the power of -2. And what do we get when we put that in? So 1 to the power of anything is just 1. So this is -1/2. Two negatives are going to make this become a positive. That is 1/2 times 4, because you would flip that. And so what's -1/2 plus 4 on 2? We should get that that is equal to 3/2. Final answer. All right, I'm going to pause the video here, and we'll come back and we'll look at how to use the substitution rule to do a velocity question.